positive. So I wanted to define it for you in case you'd never seen it before, but the fractional exponent rule, it basically takes it and writes it as a radical. So before, we've only ever had a numerator. Now this denominator is in charge of the radical. So this is really the nth root of x to the mth power. So it makes it into a radical. So it could be a square root, a cube root. So it says, in other words, a fractional exponent means you find the nth root of the expression raised to the m power. So it's not multiplying by a half. That's the biggest thing I can emphasize. There's no multiplying going on. You're rewriting it using a radical. So this is going to be the square root of 25 to the first power. And the square root of 25 is 5, and 5 to the first power is just 5. So I always do the radical first, and then I'll, multiply it or whatever. All right, so the next one. This is going to have me take the square root, because 2 is in the denominator. The denominator is what's new. That's what makes your radical. And then 16 cubed. I do not know 16 cubed in my head, so I always do the radical first. What is the square root of 16? The square root of 16 is just 4, and now I can do 4 cubed in my head. 4 times 4 times 4 is 64. So without a calculator, you want to make it smaller before you make it bigger. I'm going to skip down to number 8, and then I'm going to have you go back and do a few of these for practice. What does a negative exponent do? We just learned that a negative exponent takes the reciprocal at the end, right? So this is really the square root of 4 to the negative third power. So it's like 3 steps instead of 2 steps. First, I'm going to do the square root of 4, and the square root of 4 is 2. Then I'm going to do 2 cubed in my head. 2 cubed is 8, right? And then I'm going to take the reciprocal of 8. So the answer is 1/8. So that negative sign is in front of the fraction. And I want to draw your attention lastly to number 13, because 13 has a negative sign that's in front of the number. So now the negative is just part of the number that's under the radical. So number 13, 3 is your denominator, so you're taking the cube root of negative 125, and then you're squaring it. Can you take the cube root of a negative number? Or let me go back. Could you take the square root of a negative number, like the square root of negative 4? We said you can't, right? But a cube root is different. What times what times what will give me negative 125? Does anyone know the cube root of 125? Come on, table of powers. What power family does that have to be in? It ends in a 5. All right, so 5 to the first is 5, 5 squared is 25, 5 cubed is 125. So the reason I can take the cube root of a negative number is because I can do negative 5 times negative 5 times negative 5, and it will give me negative 125. So the only thing you have to be careful about, this really is in parentheses because the negative was in parentheses up here. So what happens when I do negative 5 squared at the end? I get positive 25 as my final answer. So to me, this is a challenging problem, the cube root of a negative number, and then you end up squaring it and it becomes a positive number. So I'd like you to go through the other 12 problems or so and always write them out using your radical. Don't try to shortcut it. And then see if you can simplify each of them to just a single number. So for number 3, and this might be a rule that you've never used before. To me, this is something sometimes we skip in Algebra 2, or you might not have seen it. So We're doing the cube root of 27, and then we're going to square the answer. So this becomes 3, and then 3 squared should have given you 9. Does that look right? Does that make sense what you got? Let me do 4, 5, and 6, and then if you haven't had enough time to go through the rest of them, I'll give you a couple more minutes. So the denominator is what goes outside of the radical, right? So I'm doing the 5th root of 32. If you look in your power table, it ends in a 2. So it's probably a pretty small number if you're doing it to the 5th power. It's actually 2 to the 5th is 32. So we're really doing 2 squared, so the final answer would be 4. And that would be a hard one. You should know the powers of 2, though. 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. So if you don't know those, you will at the end of this unit, or you should at the end of this unit. Number 5 is just asking you the square root of 49, right? Because to the first power, that won't change it. So the square root of 49 is just 7. You're not dividing by 2. Number 6, it's the square root of 9, and then you're cubing it. And I don't know 9 cubed, so I'm going to do the square root of 9 first. That makes sense, right? Square root of 9 is 3, and then 3 cubed should be 27. All right, so on number 7 is a tricky one because you're taking the cube root of negative 27, and then you're going to take the reciprocal of the answer at the end. So the cube root of negative 27 I can do. That answer would be negative 3. And then I have to take the reciprocal of that negative answer. So I'm going to get negative 1/3 as my final answer. Anything for 0, 0 to whatever power will always be 0 because 0 is the base. So number 9 should have been 0. On 10, I'm taking the 4th root of 16. Then I need the reciprocal of the answer when I cube it. So the 4th root of 16 is 2 because 2 to the 4th power is 16. And then I need to do 2 cubed, which is 8, and I'm taking the reciprocal, so 1/8. So to me, number 10 is like the hardest type of problem, that you'd have to do without a calculator. Same thing with like number 11. This doesn't have any negatives, but it's the square root of 16 and then the 5th. I need a calculator for this one, right? Because I don't know 4 to the 5th power. So I would not expect you to be able to do that without a calculator. 4 to the 5th is 1024. Maybe if you had your power table, you could do it. But you should know the cube root of 64 by heart. That's 4. Perfect cube. 1 to any power is always 1. And then 15 is actually undefined. Did you figure that out? Can you take the square root of negative 16? No. And if you try to do it on the calculator, you'll also get an imaginary or non-real answer. So in this case, these parentheses were really important because that's what sucked the negative 16 under the radical. If it hadn't been in parentheses, it would really be negative 1 times 16 to the 5 halves. So you could do 16 to the 5 halves and just make your answer negative at the end. But this would be no solution, or you could write undefined for that one.